one of the points of doing this assignment was to have everybody put a probe in pinpoint and sorry, angle it at some angle, rotate it so that it's off axis somewhere, drive it over to some target. So if you did the assignment, you should have done something roughly like this. And I'm happy to talk through what I just did if anybody had trouble with the controls themselves. So this is a recording that's going through a visual area, CA1, DG, and then driving down into thalamus. And part of the point of doing this was if you go and you try to do this in the Paxnos Atlas, the PDF that I sent, you'll find that this exact insertion doesn't exist. So if you go 2 millimeters back from Bregma, which is this coronal slice here, you can't drive through a visual area and go through CA1 and drive down into thalamus. You have to go farther back. And this is just a sort of fundamental truth of mouse atlases, that they do not exactly match each other. So I wanted to bring that up because people are always confused about this, and this is the opportunity to remind people that this is true. So feel free to drop a question in the Q&A if you want to discuss that more, but otherwise I'll just answer questions now. Okay. So there's a question about changing the Bregma lambda distance based on the animal, and how you can use that to get individualized coordinates. So right now this setting is a little crude. So for anyone who played around with Pinpoint, you know that there's a bunch of settings here. There are settings that control the probe specifically, settings that can turn on these different sort of rig relative things like the mouse skull. There's some settings for areas. You can switch atlases in this atlas dropdown, and one of the settings in the atlas area changes this transform and then scales the actual brain. So the idea with that is that the atlas itself has a known distance from Bregma to lambda of a little more than 4 millimeters. And the thought with this is that if your mouse is larger, you can increase this distance and it will scale up the brain. It's a little hard to tell that it happened, but this brain is slightly bigger than it was before. And the hope is that that translates to better targeting accuracy. This is actually not something that we've ever been able to fully test. So I can't promise it works. It should work in principle, and we're doing an experiment now to check that it works, both in Nick's lab and at the Allen Institute. So I hope to have a real answer about that eventually. There's a question about Pinpoint and Spike GLX. So I'll point people again to the website here, where there is a tutorial section. This is virtualbrainlab.org. And there's a section here about the API and the connection to Spike GLX. I won't show it live, but basically when you're running Spike GLX, there is a server that needs to be turned on, and there's an explanation of how to do that. And then in Pinpoint, there's an API section here, which is disabled for me right now because I'm running in the browser. But if you download the Windows version of Pinpoint, you'll be able to connect between the two. Someone asked a question about how to perform insertions with angles. The angles are controlled by these yaw, pitch, and roll settings. So I'll just show you quickly what this looks like by resetting this probe. In Pinpoint at rest, a probe with no yaw and no pitch points forward with the electrodes facing up, so dorsal. As you pitch the probe up, so if I go up by 15-degree increments, you can see the probe is lifting off of the sort of surface of the recording table. Hopefully that makes sense. So I had this probe at about 75 degrees. And yaw is just the rotation around the dorsal ventral axis. So when I press 1 and 3, the probe rotates to the left. So this is minus 90 yaw, or off to the right, plus 90 yaw. And these are just conventions that we've come up with in Pinpoint. They are translatable into other conventions like the ones the IBL has used pretty easily. Do you click relative to Bregma before setting the coordinate? I'm not exactly sure what that means. So by default, the probe starts at Bregma. This is a setting. The relative coordinate here, the reference coordinate, is a point in the CCF atlas. And then all the movements that I make are then relative to that. So when I make one movement posterior on, I'm using W and S right now to move on the anterior posterior axis. When I press S once, I'm moving 1 millimeter back on that axis. So everything is always relative to that reference coordinate. And then a technical question, would it be possible to go in horizontally from the side? In pinpoint, yes. I can make my probe flat. I can move it down to the side, and I'm now going in through the side. Hopefully it's obvious what just happened there. In an actual mouse, this would be very hard to do. And I would talk to folks who've tried these surgeries first before trying to do a surgery like this. It's much easier to open up the top of a mouse's skull than it is to do a clean surgery that goes into the side. But I suspect there's somebody out there who's doing it.
Can I maybe add it to that? Because there was a question yesterday on Slack as well, whether we can combine Neuropixels with to photon imaging, for example. And I think, if I'm not mistaken, you have some things to kind of check compatibility with other, is that true? Like if there's a wide field lens, for example, above, or
Yeah. This is a good point. So in the rig settings here, there are some things that you can add. We'd like to make this much easier to add. That's one of our Pinpoint 2.0 changes that's hopefully coming soon. So these rig things are sort of 3D models that you can add. So for example, turn that off. This is like without the implant well. This is one of the setups that the IBL often uses with a head bar sort of in the front or in the back like this over the mouse skull. And the point of having these in here is that you can quickly check whether a particular probe angle is going to be possible. And the program will tell you if there's collisions. Same thing if you add multiple probes into the scene and crash the probes into each other, the program tells you when probes are colliding with each other. And so specifically to your question, in our lab, in Nick's lab, this happens to be the wide field lens setup. It's a particular objective size, a particular distance from Bregma. And so we use this to check whether particular angles of probes are going to be possible based on our specific setup. We can add more of these. And like I said, it's something we'd like to make easier to do, is to add these. I'll take one more question, then pass it off to Olivier probably. Maybe these are pretty quick. I notice we can have different pitch and roll values to target a region. The probe can have different positions. Yeah. So there are many ways to target a region, right? If you pull up some part of the brain, whoops, I can't see what I'm doing. Right. So here's VisP. So of course you can get a probe into VisP in any configuration that you want, just rotating around in different ways here. There is no best configuration. Yeah. I would say that I think people have looked at whether doing things like flipping your probe upside down is a good idea or not. Here I just rolled the probe 180 degrees, so it's upside down. This kind of stuff doesn't seem to make a difference unless you're also doing wide field at the same time, or other calcium imaging, or doing optogenetics where you have light that might activate the electrode sites specifically. And then I'll take one last question. Let me reset this because this is important about DV and depth. So this came up on Slack, and I'd point people there as well if you have more questions about this. If you move a probe on the DV axis, you'll notice that both the DV value and the depth are changing here. And the reason this is happening is because the coordinates here, change this. So this APML DV value here that you're seeing are the coordinates of the entry point relative to Bregma. And the depth is the distance from the entry point down to the tip of the brain. So as I move this probe up and down on this axis, that entry point is changing. And that's why both DV and depth are changing. you should play around with that yourself in Pinpoint if that didn't exactly make sense. The point is the 3 values here are the entry coordinate relative to Bregma, and this value depth is the distance of the probe down from there. I should probably stop there. I'm already 2 minutes over my time and pass it off to Olivier.